Okay, once more again, good afternoon. Thank you for your time that you are ready to listen us for more than 1 hour. The name of today's webinar is an overview of our 80 gigahertz 1150 megabits full-duplex PtP links with range up to 5 kilometers. Before we will fully concentrate on technology, short introduction. It's about company Sub10. If you don't know who Sub10 is and who is behind Sub10, we are a private company. Our headquarters is located in Newton Abbot, which is south of the UK. And our main focus and 100% focus is on development in a new band, which is called millimeter wave. We are providing technology running in 60, 70, and 80 gigahertz, which is called again millimeter wave. Some key milestone in our company. In middle of 2011, we overtaken the solution from company Huber and Sooner, which is original 60 gigahertz solution. Now we are still maintaining, developing this solution, and we are also working on our pure products, which is coming from our developers team. During our business or sales opportunities, we found that it's not enough to have just this millimeter wave solution, and we need more than millimeter wave, and we have cooperation with company which is called Repeated. Repeated, it's located in Sweden, and this company it's focusing mainly on 2.4 and 5 gigahertz. Some people are calling it Wi-Fi type of products, but it's not pure Wi-Fi. It's running on 11 and chipset and running some proprietary protocol providing PTP and PRMP solution. And next very key point in our history, it's September 2012 when Alcatel-Lucent and Sub10 signed agreement about integration of our 60 gigahertz solution in Alcatel-Lucent portfolio. It's very shortly about company. If you need to more, you can go to www.sub10systems.com and you can find more who is our management, how many people is working company, and so on. The picture or building which you see on picture, it's our headquarters, and the small pictures are from inside house. It's, you can see here, production line, testing line, and it's really important to know that we are not just putting some pieces together. We are doing pure development, and production is also managed by us. We are not doing some processing in China. Everything is done in the UK in our headquarters. I receive message to increase the microphone. Unfortunately, it's not. I am on full. It's better now a little bit. I will try to speak more loudly. Regarding the millimeter wave products, what we have today in our portfolio are products which are called Liberator and some letter plus digit for identification. Today we will focus on this one product which is on the bottom, but to have complete overview, we have Liberator VC20 and also V100, which is and V1000. These products are, as you can see, running in V band. It's frequency between 57 and 63 gigahertz. Difference, and this difference it's indicated by number. It's in user throughput which is available. V1000 it's gigabit, VC20 it's 320 or 160, and V100, which is really new one, it's supporting 100 user data throughput. Important is these systems are running FDD, and if we are speaking about 100, it's 100 full duplex. You have bidirectional 100 or two stream, one from left to right and another from right to left. As next, it's Liberator E1000. This is different frequency. It's working in frequency 71 to 76 and 81 to 86 gigahertz. And user throughput, user capacity for this product, it's 1150 megabits. And this system can go up to 5 kilometers. This 5 kilometers, it's related to no rain or dry condition, and I will explain later during presentation how rain and other parameters are affecting maximum length. As I don't know what is your background, what is your level of knowledge, I put a couple of slides about millimeter microwave. It's relatively new. It's 2-3 years maximum on the market. and I think worldwide use abbreviation is now MMW, which is abbreviation for millimeter wave. If you calculate what is length of the millimeter of the signal running this 60, 70, 80 gigahertz, you will just see that it's a couple of millimeters, and this is why generic name it's MMW, which is abbreviation for millimeter wave. If you look for the complete band, millimeter wave, if you are going exactly for calculation, are starting on 30 gigahertz and going to 300 gigahertz. But frequency around 30 gigahertz are also called traditional microwave. You know that there are systems 32, 38 gigahertz running on as millimeter wave technology. And today millimeter wave, it's mainly these columns on the right. The yellow one, it's around 60 gigahertz and it's named V band. Remember, we have the product V300, V320, V100, V1000, and they are running on frequencies between 57 and 63 or 62 gigahertz. And second, it's called E band, and this is this green bars, and the most now used part it's from 71 to 76 and 81 to 86. And this is what we will focus now on, this green band, which is called E band. If you are designing any radio link, you have to make so-called link calculation. This link calculation is saying what can be distance, what will be availability, what antennas I can use or I have to use, and so on. If you are looking for real calculation, you have to look for three key inputs. One is called free space loss, or free space or free path loss. You can see FSL or FPL, and this is loss which is not related to atmosphere or environment. It's calculated by one formula, and it's the result. It's always related just to frequency and distance. The second parameter, and this is very important for V band, it's absorption, which is related to oxygen. That atmosphere, which is some percentage of oxygen, it's doing attenuation. And last parameter is loss, which is related to weather condition. And weather condition in this case, it's just rain. If you have rain and it's really heavy raining, it's providing additional attenuation, which and during design you have to design the link to be able to compensate some level of the rain. If you know these three parameters, there is a couple of formulas, and you can simply calculate what will be link availability. It's looking like almost like academic task or some big homework. Don't worry, at the end of this explanation I will provide you link estimator, which is Excel sheet and very easy for calculation. You just need to put some key parameters like location, what is the length of the link, and what antennas will be used, and system automatically calculate what will be link availability. Just to have knowledge which is really required for understanding, if you are thinking about link availability, you can see numbers or words like 4 nines, 5 nines, 3 nines. Just remark what does mean. If you are speaking about 5 nines, it means that link is available 99.999% per year. It's called 5 nines. If you calculate what is the time per year related to this availability and rest is used for unavailability, you will see that it's 5 minutes. It means if I have system with 5 nines availability, I calculated that link will be down maximum 5 minutes per year. In a radio environment, the 5 nines, it's not used so much because in this case you have to calculate complete availability or reliability of the system. And for example, if you have one power supply which is used for powering of link, you are not able to achieve this 5 nines. What is more used is this 4 nines, and you see 4 nines difference is it's 53 minutes drop, link drop per year. And next it's 3 nines, and you see it's almost 9 hours. But for radio system, typically 4 nines are used, and it means we are able to accept 53 minutes per year of outage. And now, if I'm speaking that, okay, my link, it's 4 nines available, what does it mean for me or for some additional inputs? For these high frequency systems like 50, 60, 70, 80 gigahertz, you have to define or find level of the rain, and this is on this screen. If you are speaking about, or if you are looking for 4 nines availability, you have to find rain of or level of rain which is below this parameters. It means, like on the first example, I am looking for this dash line, and if I calculate together time 1, time 3, and time 2 together, they are providing that 53 minutes per years. And at this time, at this graph, you see that for 4 nines in office, Sub10 office, which is in Newton Abbot, the level when rain is lower than this value, it's 33.2 millimeters per hour. And now, if I am looking for link with 4 nines availability, I have to be able to compensate rain up to 34.2 millimeters per hour. If my link is able to compensate this rain level, I'm okay, and my link will work 4 nines. Only 53 minutes, rain will be stronger than 34.2 millimeters, and in this case, my link will drop down. But be careful, this value which you are looking, like this 34.2 millimeters per hour, it's coming from some statistic data. And like on this example, it can happen that 1 year it can be in 3 different times. It's probably some February, June, and September. But next year can be just in 1 month. I don't know, August, because it's like in middle of the graph. And again, there are statistical and some using some historical data. It can happen that 1 year the rain will be much stronger, but we cannot say how strong will be rain. And this is what is used by all companies, all providers, all operators, just to select this data. We know that for 4 nines we have to compensate this level of the rain, and this is input used for our calculation. Next point is oxygen absorption. I mentioned that it's mainly for V-band, and you can see how it's different. V-band, it's represented by this 64 gigahertz, and you see just atmosphere, nothing else, just oxygen in atmosphere. It's providing 14 dB per kilometer of attenuation. If you look to the 86 gigahertz, same condition, same just atmosphere, it's providing just 0.35 dB per kilometer. But for today, it's not our case, because we are mainly looking for E-band, and the oxygen peak, it's not so big. But keep in mind, in millimeter wave, we have also oxygen peak, which is important for some sub-band like this V-band. And to have some better understanding or figures, I provide you such table, and you can see there is attenuation per kilometer for frequencies. You can look, for example, 5 gigahertz. You don't need to take care about rain, because if you look even 40 millimeters per hour rain, it's providing just 0.11 dB per kilometer of attenuation. But if you look to this table, how frequency is higher, this rain, it's coming more and more important. I put this 57 and 62 gigahertz, and in columns you have different rain level, 10 millimeters, 20, 30, 40. Last column, it's called others, and this is attenuation which is going from atmosphere, from there is some oxygen, the atmosphere has some humidity, some temperature, and so on. And you see this yellow areas which are the most critical for link design. Again, in V-band, it's mainly atmosphere doing the big attenuation, plus of course rain. In E-band, atmosphere is not so critical, because it's still around 1 dB per kilometer, but rain, you can see it's going from 6 for some light rain, around 10 millimeters, but it's 16 for rain which is on 40 millimeters per hour. Just to have idea how it's affecting the link, you have this table. If I'm looking for the last line, it's free path loss or free space loss. It's always here, this attenuation, and it's just related to frequency and distance. And you can see that this free loss, it's not so increasing. It's starting for 1 kilometer on 131 dB, and it's 145 dB per 5 kilometer link. But if you look for the rain, how it's adding additional attenuation, you see if it's no rain, we are receiving just additional 5 dB per 5 kilometers, which is still okay because we are able to compensate it. But when the rain is going more and more, we are going to troubles, because if you look, for example, for 40 millimeters and 5 kilometer link, just rain, it's producing additional 86 or 87 dB. We have 145 for free space loss, which is totally 220 something. Oh, it's 230, and there is no system which is able to make such compensation. Plus, if you look for dynamic range, if I have 5 kilometer link working and still working in rain level 40 millimeters per hour, you see that the dynamic range, it means how transmitter and receiver can fluctuate, it's almost 90 dB. And it's if you are familiar with radio technology, it's not so easy to make system with so high dynamic range. And this is what is disadvantage for our regions, that E-band, it's affecting by rain, and we have to always calculate the rain, and this rain, it's limiting or decreasing maximum distance, maximum length. If you are more familiar with this rain, there are so-called ITU rain zone. They are using the letter for indication. There is zone A, B, C, D, and you can look on this map. You can find it in ITU recommendation. The number is PN-A37, and you can find such map even more detailed that you can see just for Europe, and you will see what region it's in what rain zone. Again, it's just to have overview what is how this link availability calculation is done in our tool, which you can download from our web page. Everything is integrated inside. You don't need to take care of what rain zone. You can just put coordinate, system automatically select the right inputs value. You have to specify what is the link distance, and system will calculate what will be availability of your link. This is how looks like this tool, but I will now switch to live tool. There will be another screen. I hope you see now the Excel sheet. This is the new or the latest version. You see it's from this month. It's number 187, and you have a couple of sheets here. But first one is the most critical because it's called link availability calculator. And easy, you can see easy identification. What is the functionality? Items in blue. I'm sorry, my screen. Do you see, John? Do you see the Excel sheet? Because I see that screen is pausing for some reason. Yeah. Okay. And you see this light blue items are for editing. You can specify some location if you want, but the most important is I will start with coordinates. I am living in the Czech Republic, and I will use Prague as Prague coordinates. We have old downtown, which is on this location. And I would like to create this 5 kilometer link. What I have to do, I specify just the coordinates, what is the link length in meters, and then I have to go down and specify, or I can specify antenna. You will see later that we have two different antenna. We have 35 centimeters antenna, and we have 65 centimeters antenna. For both, you see that my availability is not so good, and it's okay, because if I am looking, system is calculated that 4/9 rain availability in my region, in the Czech Republic, it's 35.1. In this case, I will decrease. I will use 3,600 meters, and still, because rain is really high, I am not reaching 4/9 availability, which is something like my inputs as well. I will put 3.4 kilometers. It's okay. 3.5. It's also okay. We can stay on 3.5. And this is calculation of the link. You see output power, it's maximum 20 dB. Antenna is 65 centimeters. And availability will be 4/9 and something small. It means 50 minutes or 51 minutes per year will not be available. Oh, I see that screen is frozen a little bit. Okay. This is this basic calculation. You have to specify your coordinates, link length, antenna, and you see what is the availability. Inside the tool, you have couple of pages. The next one is link alignment, and this one is providing you, if you are familiar with radio system. We have BNC, which is output providing DC voltage level, and you have graph that which is providing you relation between receiving level of the signal and voltage. For example, on this graph, if you look, for example, your receiving signal will be -50. On DC voltmeter, you have to measure 2.5 volt, and this is the key parameter used for alignment during the link installation. This is this link alignment tab, and last one, which is useful, it's link budget calculation. And here you have all important points which we used for calculation. You see what is the frequency, it's middle frequency used for calculation. You see coordinates. Sorry, it's again paused. I hope that that you see it, because I have some issue with this Excel, that Excel is always trying to pause webinar. You have information about length. You have setting for TX power, what is antenna gain, what is the sensitivity of receiver, what is total system gain, and you have also warning that in this case, if you power everything up, your receiving level will be too high, because there is some limit what can be lowest signal on the receiver side, and you have also the calculation of availability. There is different calculation for vertical and horizontal polarization, and it's logical, because the raindrops, they are not like ball, they are like ellipse, and in one direction they are longer than in opposite direction. And this you can simply copy it and use as part of your offer. If customer is asking for link calculation, you can simply copy it from this Excel sheet and put to your documentation. As I mentioned, it's available from our web page. If you go okay. If you go to the www Sub10 System, full-duplex.com. You have here products, you have section downloads, and you can simply, okay, I will wait. Okay, now everybody has updated the screen, and if you go to the down, you have additional information, and there is a link availability calculator. It's Excel sheet. You have to enable macro to run all these calculations. Just check time to time whether there is some newer, because we are usually every 2-3 months doing some update, adding some new features, new products to this calculation. Okay, back to our presentation. Oh. Okay, it will be faster to go. Okay, now we will focus on E1000 link to provide you detailed description. If you look using some schematics or some generic pictures, our E1000 and also our V-band products, it's like this example. It's layer 2 device. It's doing PTP connection. And important is that you have your infrastructure, which is, for example, switch, router, or it can be some PC. Then you have cable, which is Cat7 cable. And over this cable, we are sending data, which is this green. And we have also using the power injector and putting power sending to the wireless link. And it's useful that you don't need to install more than one cable. You can just use one cable, put everything together. And if customer is asking for optics connection, it can be also, you will see later we have more user ports, but basic installation is like this one, that you have one metallic cable which has to be Cat7, or our suggestion is to use Cat7 cable, and over this cable you are sending data and you are sending power. This is basic schematics of our solution. If you look for pictures of components, you see here everything what you need to set up the link. Starting from the top, in outdoor, I didn't mention before, but this is full outdoor solution. And on outdoor part, we have two components. One is ODU, which is outdoor unit, and second it's antenna. ODU, it's connect directly to the antenna. It's clip to antenna. And why we have these two pieces? It's logical because we are providing two antennas, 35 and 65 centimeters. And it will be not so logical to have everything in one, because in this case you have more items for production. Now we have ODU, which is universal, and ODU is clip on antenna, and antenna size it's coming from your link calculation. This is outdoor, nothing else outdoor, just these two parts, ODU plus antenna. In indoor, we have two main components. One is called protected terminal box, and this box is putting together data and power for ODU, and you have to have power supply. We are able to deliver power supply to you, but if you have already installed 40 volt DC power supply on the side, you cannot. You can simply use this one, but keep in mind that it's using 40 volt DC, and you have to have this 40 volt DC available. And then you need some cables, and as I mentioned shortly before, we have two options: STP cable, if you are preferring metallic type of connection, and optical cable. You can use optical cable instead STP. If you are using optical cable, you have to also install some metallic cable to provide power to ODU, because there is no way how to send power over optic cable. These are these components. Regarding characteristic of our system, in this something like marketing overview, it's here. It's all outdoor solution. It's running in 70 and 80 gigahertz band. It means it's FDD, frequency division duplex. You have one frequency from terminal A to terminal B, and another frequency for terminal B to terminal A. It's simple, you can say two-box system. You have ODU plus antenna, install it outdoor, and protected terminal box, install it indoor. For user, we have 1.15 gigabit throughput, and latency is very low. On one unit, we are providing latency less than 8 microseconds. Regarding type of traffic, you can configure what size of frame will be supported. We can support just 15-18 bytes, which is standard Ethernet. Next configuration is 2000, which is supporting Q-in-Q or more tag or frame with more tags. And if you are using it for some, I don't know, storage, for some SAN networks, you can also allow jumbo packets, and in this case, frames up to 10,240 bytes are sent over the link. We have two models of ODUs. One is coming always, all ODUs are coming with 2 gigabit ports, metallic gigabit ports, and as option you can order a unit with SFP port or optics port installed. For this optics, we are supporting single mode and multi-mode. In this case, we have like 3 models. We have just 2 gigabit metallic. It's model 1. Model 2, it's 2 metallic gigabit ports plus multi-mode. And model number 3, it's 2 gigabit metallic ports and 1 single mode optic. As I mentioned, operating range up to 5 kilometers. In some dry areas can be even more. But for our region like Europe, UK, we are speaking about 3.8, 3.5, 3.4 based on rain level. Remember, the rain calculation or rain attenuation, it's always related to your geographics coordinates, and it can be 32 millimeters for one location and it can be 40 millimeters for another location. ODUs and protected box, they have overvoltage inside. You don't need to install additional surge protection equipment. It's protected by this integrated overvoltage protection. It's easy for installation because we have just a couple of components. Everything is using standardized connectors, cables. You can use browser for basic configuration, and we have special utility which is called Sub10 control system to provide management of the link. I will show you later on this SCS on live link, and it's this utility. It's free. You can receive it from us, and advantage of this utility is that it can be used either for management of one link. This is called TCP/IP mode, that you are just specifying IP address of a link which you would like to monitor. But we can also activate network mode on this utility, and in this case, up to 50 links can be managed from one SCS application. And in this case, it's useful if you have just couple of links. You don't need to install some huge management system. Just one computer, it's enough, and you can run this application and you have immediately online status overview whether everything is okay. It's using this color green, orange, yellow, and if you need more detail, just double click on a link which you would like to see and you see all details immediately. And what is the advantage of E and V band? In many countries it's license free or license exempt band, and if you calculate now and if you look generally inside Europe, the regulatories in each country, they are now trying to earn more and more, and they are typically increasing money for license band. It's not because they are just trying to earn more, but if you are looking for traditional microwave band, like I don't know 13, 18 and so on, it's really overcrowded in big cities, and they are simply trying to use it efficiently, and they would like to avoid situations that somebody is just putting a couple of links on these high frequencies just to have better connection than it's really needed. In this millimeter wave, it's different story. If you look just for available capacity in V band and E band together, it's 19 gigahertz available for this PTP microwave system. If you look for rest of spectrum, starting from 2.4 going to 48, it's not so huge. You have in each subband, you have a couple of hundred megahertz only, but in E and V band, we have 19 gigahertz available for PTP application. More details about each component. Terminal box or terminal protected box. It's indoor unit. It's protecting data. It means it's using surge protection on cable which is going from terminal box to ODU. But you can also see that there are two power inputs. This box is designed that you can use two independent power inputs, and to have running link, it's enough to have at least one power input up. It's typical for telco environment. If you have big room with a lot of technologies, a lot of units, they are using power line A, power line B, and if there is some maintenance, they know that each unit are using double power, and you can simply switch off line B, make some maintenance on line B, and then power it up. You can use it on our system as well, two independent power inputs, and then you have two output ports. It's called line 3 and line 2. Remember, the total capacity is 1.15 giga, and we have just gigabit port on it. And this is how you can access the rest capacity, that you can, for example, make 2 or 3 gigabit port or 1 gigabit and 2 fast Ethernet ports going to the system. And this is what system is providing. 2 gigabit port metallic are coming with all units, and you can you can split total capacity, which is 1.15 gigabits, between these two ports. You can do it, as I mentioned, for example, full gigabit or 100 or fast Ethernet port, or you can split differently. You can specify, okay, line 3 will be 500 megabits and the rest will be on line 2. In this case, you will have line 3 connected as 500 megabits connection, and the rest, which is 650 megabits, it's using for line 2. This is protected box. Regarding application, you can use it on DIN rail, that there is the connection for this DIN rail, but we have also accessories how to mount it to the 19-inch rack. Regarding antennas, you see picture of bigger antenna, which is 65 centimeters, but we have also smaller, which is 35 centimeters. What is difference? As you expect, gain and also weight of the antenna. The small one, 35 centimeter, it's just 48 dBi, and weight it's around 8 kilos. 65, it's providing 52 dB, and it's 11 kilo. Regarding ODUs, I mentioned that we have 3 types of ODUs based on the user ports. Always 2 metallic gigabit port, or it can also run as Ethernet or fast Ethernet, but gigabit it's the maximum speed. And you can order unit with optics mode. Because this system is running as FDD, we have also naming which is typical in such configuration. We have one terminal which is named Terminal A. It's operating as a transmitter in lower band. You see that his TX it's configurable in range 71 to 76, and his receive it's on 8186. TX of Terminal B it's in vice versa order. Terminal B it's transmitting on upper, it's 81 to 86 gigahertz, and receiving on 71 to 76 gigahertz. And this is shape of ODU. If you have this ODU, you can see couple of connectors and some labels on it, and there is description what is on each part. We have this big label which is providing information what is the MAC address, what is serial number, whether it's terminal A or B, and you have also description what frequency are used by this terminal. And you have the mandatory marks like CE marks, power, and so on. On connector side, you see this BNC connector, which is used for measurement. During the alignment, you see based on the receiving level of the signal, what is your okay, there is relation between measured voltage level on this port and what is receiving level on the radio side. And then you have 3 connectors. In this case, I have ODU with optical ports because I have 2 groomed or cable gland for metallic cable. These are always on the unit. And then I have this black one, which is bigger one. It's optional connector for for fiber connection. Next point is grounding. It's important because you are installing this unit outdoor, typically on some mast pole, and it's important to have proper grounding. And there is also user terminal space when cables are connected. You will see later some more pictures. We are using Krone distribution frame for easy termination of cables. Some more parameters about antennas. Important is if you look for the main lobe. The lobe, or antenna beam, it's very narrow. If you see for smaller antenna, it's just 0.4 degrees, and for bigger one, it's 0.3 degree. It's not mistake. It's really so small one. It's important if you are doing alignment and if you are not so familiar how to make microwave systems. Be careful that you need to be very precise and move slowly with units or with antennas to be sure that you are directed to the opposite side. If you are without any experience and you are immediately going install 2 or 3 kilometer link, you will be probably in trouble. Our suggestion is test it on some known environment, or this month there will be also another webinar. We are able to provide you service that, for example, for first link, when you are limited knowledge, limited experience, we are able to help you with installation, to help you during the alignment, to provide you hands-on practice, and so on. It will be, I think, end of the May, there will be another webinar about the services, and one of services is how to make or link installation or link commissioning. This is about antennas. I will skip it quickly to have more time for rest of part, but you see it's really professional. You have very solid and stable parts for alignment. Production, it's not using some plastic components. Everything is metal and high quality and precision preparation. Regarding antennas, on our web page we have assembly guide. You can read it, what are all components, all pieces for antennas, how to put together. It's for 60 and 35 and 65 centimeters. Just detail, this is mounting brackets, which is used for fixing antenna on the mast and also using for alignment. And this is how it's complete. This protected terminal box I mentioned, you can install it to 19-inch rack, and in this case you just need small pieces. It's L bracket and some interconnection. Final configuration, it's like this one, that we have 3 units, and you can put these 3 units to 19-inch rack, and size it's 1U. It's just this couple of centimeters. Power supply. If you don't have power supply and you would like to receive everything from us, we have option for power supplies as well. We have like 2 class of power supply. One is called basic. It's real just power supply, providing enough power for 1 or 2 units. If you are doing some collocation, you can use one power supply with higher capacity for 2 units. And then we have enhanced power supply. As you can see on description, this enhanced power supply, they have as default option to provide charging for battery, that you can connect some battery to this power supply, and in this case you have uninterruptible power supply because you have AC voltage going to this power supply. Charger is charging battery, and from the battery it's providing power to the system. And top class, it's again with charger for battery, but we have also IP management, that you can connect this power supply to your data network, and you can read what is the actual status, like temperature, status of battery, power consumption, what is input level, and so on. It's again for some high critical, or if customer is asking for some high redundancy and more reliable solution, it's useful to use such power supply, because in case that there is trouble with power supply, you have this information before you have some drop on the link. Because if for example AC input is down, you will see it immediately from this power supply, and battery are able to hold a couple of minutes or hours based on the battery size link running. Metallic cables, we have also these cables in our portfolio. We have 3 types of cable. One is standard indoor Cat7 cable. Second, it's outdoor cable, again Cat7, and we have also special cable which is called 4+2, and this cable has 4 pairs which are using 4 gigabit, and there are additional 2 pairs which can be used for fast Ethernet or Ethernet connection. And this is how it looks like these cables. And this 4+2, it's it's the last one. And you see I have 4 pairs which are in foil. They are shielded by aluminum foil, and they are real Cat7 gigabit Ethernet pairs. They are ready for gigabit Ethernet connection. And then you have 2 additional pairs which are here, and you can use this for Ethernet or fast Ethernet connection. Because for fast Ethernet you don't need 4 pairs, it's enough to have just 1 pair. And the typical application is that you have gigabit for user data, and you have dedicated, totally separate channel for management, which is using 100 megabits capacity. Regarding optical cables, there is just one point for remembering. It's on ODU we are using connector which is called Molex. It's industry type of connector providing water protection, because it's installed outdoor, typically on some mast towers, and this Molex connector provides enough protection for some. It's doing waterproof protection. If you are not familiar how to do Molex, because it's not so common connector, it's like connector, big connector, but inside are 2 LC connectors. If you are not familiar with Molex, you can order from us cable. As default, we have cable which is 10 meter length of 10 meters. But if you need more, you can even specify, okay, I would like, I don't know, 157 meters, and we are able to deliver a cable with this one. And if you look, it's looking like LC on one side, and it's really LC connector on one side, and big connector is Molex, which is doing connection to ODU and making this connection waterproof. There is example if you need cable different than 10 meters, how to do it, but we can skip it. You will receive later on this presentation. And the most important, if you are doing first link specification, some build of materials which you need, there is basic table what you have to order or what you have to specify. You see, you have to specify one part number which is called link. In this case, it's part number 27 at the end, and it's Liberator E1000 with 2 gigabit metallic interface. You have to specify just quantity 1, and this one part number, you have under this one part number we have 2 terminals, terminal A, terminal B, and 2 protected terminal box. In this case, you don't need to think about terminal A, terminal B. As default, you receive under one part number these 4 pieces. Then, based on your application, you have to specify antenna. In this calculation, it's with part number ending 30. This is the antenna, 35 centimeters. You have to specify 2 such antennas. You have 2 ODUs. Then, if you have no power supply, no 40 volt ADC locally, you have to order at least 2 power supplies. And then you have to order some cable. Because I'm using metallic, I put 180 meters. The limit between the ODU and active device is 100 meters. It's coming from gigabit specification. And what is typical recommendation that between ODU and protected box, you are putting up to 90 meters length cable, 90 meters, and then you have 10 meters from protected box to your switch, router, or to your network infrastructure. Okay, it's all about what are the components, what are part numbers, how to order. I would like to ask John if there is some question related to this topic. Okay, probably no question because I don't see any comment from John. I will continue with this link commissioning, alignment, and so on. We are working on a webinar, which is good that we can be anywhere around the world. Disadvantage is that we cannot touch equipment directly. I put some key pictures about these components. First one is how it looks like inside the cable termination on ODU. This is on the left side, and on the right side you have picture from protected terminal box. You see there are this Krone box. It's a standard used in telecommunication industry. Reason why we are using Krone and not RJ45 is to be sure that we are delivering enough power to our ODU. If you are looking for maximum consumption, it's 800 milliamps, and RJ45 connector, it's not designed to provide such high current. And this is why we select this Krone to have stable connection between protected box and ODU. It's easy to do it because you have tool how you fix the each wire, and in each box you see there are the paper labels with color. You cannot make mistake. You are just simply following the colors. And this is how it's terminated to the cable inside. Antennas, as I mentioned, they are assembly guide. I put just one screenshot, but you see on our Sub10 Systems you can download PDF file about assembly installation for both sides, 35-65 centimeters. Then again, it's coming from documentation. It's about alignment. You see it's installed ODU with 35 centimeters antenna, and you have couple of bolts and nuts doing alignment. You have this one for it's for vertical alignment, and this one for horizontal alignment. You have always one nut or screw as fixed or locked, and second it's doing the alignment. But it's just in the just example how it's done, that you have couple of nuts or screws to doing alignment, and before alignment just go to the user guide and check what screws or what nuts are used for what reason. Okay, and another user data and user management or management of the link. Now it's a couple of key points. I think now there will be no time to check everything and to remember everything, but just keep in mind that our system, you have always at least 2 ports, because all the ODUs are coming with 2 metallic ports. And if you order optical port, you have additional port. You have totally 3 ports on the units. And this is what is like physical connection to radio link. And this physical connections can be split or can be configured in 2 different modes. One is called one channel. In this case, one channel means that all user ports, all metallics and 1 optic ports are going to one switch, and this switch is directly connected to the radio transmission. Second option is cross channel. In cross channel you are doing like 2 pipes, and these 2 pipes are sending over radio independently. It can be useful, for example, if you really need to dedicated management, that you can separate physically management data from user data. And second application, if you have 1 connection and you would like to share this connection with 2 totally different customers, you can do it physically on this way, that you will have line 3 used for customer 1, line 2 for customer B, and they are totally independent. They will not receive any traffic which is not for this local customer. It is really doing physical separation. In this case, you have like 2 pipes in radio, and this is how we are also specifying capacity. You are always saying capacity for line 3, and if it's line, if configuration is 1 channel, in this case you have limitation on a radio level. If it's cross channel, you are saying what capacity will be for line 3 and what will be for line 2 and line 4. And regarding management, you have also this option. For example, if you separate user traffic and management, and you will use line 3 for user data and line 2 for management, in this case you have possibility to configure system as cross channel. Line 3 will go to the big pipe, which will be 1 gig, and line 2, line 4, which will be used for management, will go to rest, which is 150 megs only. It's looking like too complicated, but next screens will explain you a little bit more in details, and these screens are coming from documentation. If you are not so sure what are the configuration, you can ask directly me or John, or you can also read the documentation. This is first example. I have configuration 1 channel, and you see there is Ethernet switch. This switch, it's connected to all ports. You see here is line 3, you see line 2, and you see also SFP, which is optical connection. All these 3 ports are going to Ethernet switch, and this switch is connected to the radio. And now this connection, the capacity of this connection between Ethernet switch and the radio, it's affected or configured by line 3. In this case, if you, for example, specify that line 3 will have just 10% of capacity, the link will not work as gigabit, but will work as just like fast Ethernet, because you are decreasing allowed user traffic from 1.15 gigabits to 150 megabits only. This is one configuration. The second configuration is cross-connect, and you see now it's looking like 2 independent switch. Right switch is connected to port line 3, and left switch is connected to line 2 and to SFP module if it's if you have ODU with SFP optics or with optics port. And in this case, you have really 2 independent ports and 2 independent pipe, and you can specify, okay, one pipe capacity will be line 3, and second pipe will use rest of the capacity. And you have option where will be management. In this case, management is going to the line 3, but if you configure line 2 plus 4, you are switching this IP management to opposite side. You have also option to use, for example, cross-connect with local management. If you are working with some big, typically telco operator like, I don't know, Deutsche Telekom, Telefonica O2, they are running independent data communication network used just for management. And in this case, they prefer not to send management over radio link, and you can do it that you can simply terminate the IP management locally. No link management will be sent in this case over radio link. Only local node will be managed from this connection, and you have to do same on opposite side. What are unit defaults? If you are in phase that you are really installing link, you see what are the default IP address. If system is coming from us, you see this A and B are pre-programmed on these addresses 192.168.1.237.238. And it's all. If you know these addresses, you can simply connect with this SCS utility or web browser to the system, and you can run it and configure as you need. I think the physical or next logical step when you connect to the unit is that you will specify your IP address. You can do it from a web interface, and for all other configuration, like what will be configuration 1 channel, cross channel, what port will be used management, my suggestion is simply use SCS, because this utility, it's very nice, it's permanently communicating with unit, and also it's programmed in a way that you cannot destroy the link. If you are going just to one unit, you can simply program something wrong in the unit, and then you are losing complete link. With this SCS utility, there is mechanisms how to check. And if your change it's doing configuration that link it's not working, the SCS is able to return 1 step back, and your link it's not lost. It's okay if you are in lab, but if you are already deployed the link and you have 3 kilometers between 2 nodes, you are sitting in some network operation center, and your link is additional 100 kilometers far from you, and you are doing something wrong. It's very useful to have tool how to go back to the running and proper configuration. And this is what is managed by SCS. If you need to install it, it's very easy. It's Windows-based program, but it's also running on Linux machine or Mac systems. It's very easy. You have just this exe installation file. Then you have to have license key, user and user list dot. These 2 files are providing license and use or accounts information. And then you have to have channel table. These channel table are available on our site as well, and if you need some special table, we can simply program it. When you install SCS, you have to know the client username and password, and this password and name is stored in this license file. This is how it looks like. When you run SCS, you see this is the main window when you have all functions available, and you have user login. You have to put username and password. If you put correct username and password, you are logged to the system. And when you configure some link, typically like this one using the IP addresses, you see immediately configuration, not only one unit, but if a link is up, you see immediately whole link. You see local station and remote station. There is now difference. If you are running in TCP mode, you see you are specifying what TCP address will be your local address, and you see just link when terminal is on this IP address. The second mode, it's network mode, and in this case it's different. You see network manager, we have just one link here, but if you have more links, you see hop 1, 2, 3, 4, and so on, and you have this green or color indication what is status. And if you need manage the one exact link from all monitored link, it's enough just double click on the line and system will move you to this link window. This is how to set up. We can skip it. I think we can now answer some question if there are some questions. I see some question, but probably it was answered by John. 4 nines, yeah, it's true in microwave systems. 4 nines, it's something like standard type of availability. If somebody is asking for higher, it's not so true, because again, in this case, you have to calculate also availability of all components, like what is availability of data switch, power supplies, and so on. In link calculation, there is question about what version of ITU recommendation we are using for our system. The answer is we are updated it, and we are just now in discussion what version. I can check. I don't know exactly whether we are using the latest one, which is A375, but this is not just this one recommendation. There is also a difference in RAIN parameters. There is like 4 or 5 ITU recommendation, and we are actively changing if how to say, professionals are deciding that this ATU is too old, we are immediately implemented in our tool. And Cat5e and Cat7 cable is generic question, and answer is yes and no. You can use it, of course, but be careful. Cat7 cable, what is difference? Cat5e and Cat6 and Cat7. Cat7 has shielded each pair, and then all these 4 pairs are shielded together. And if you are installing such cable in some on some tower where is a lot of microwave systems, you minimize potential interferences or some potential induction on cable which is between your ODU and indoor protected box. If you are installing one link on the roof, it's normally that Cat6 or Cat5e cable, it's enough. But again, our suggestion is to use Cat7. In a situation when you have more radio technology installed on one tower, definitely use Cat7. And for some end location, Cat5e or Cat6 can be used. But be careful about usage outdoor cable. It's mandatory. Do not use indoor cable for outdoor, because PVC cover, it's not so stable, especially for UV radiation. And also you have to check what is the diameter of the cable, because this grommet which are using for connection for cable going to ODUs, there has to be some diameter. If you, for example, put 5mm cable to this grommet, there will be no waterproof connection. The connection will be not stable against water, and you have some high risk that water will go to your system and damage something inside. And this is why we are using this Cat7 outdoor, because the diameter is right, protection is right, and also don't understand. There is the question of outdoor cable if it's field tested by Compact ID solution. Again, you can use any cable which will provide you good connection. And there are 2 points. You have to be sure that the diameter of the cable is right, that there is good water protection on grommets which are on the U. And also you have to be sure that there is no interferences, no induction signal going to your cable. And in case, again, if you are alone on some location, Cat6 cable will be enough. But again, be careful, Cat7 is better because everything is protected. I think I answered all these questions which I see here. Now the last part is this SES client. Okay. I hope that you see now the SES. I'm logged in as service, but I don't, or I'm not logged. I was logged before, but I log out. And this is if you start it, what is happening? You see this username. You have to specify your account. And log to the system. Now I'm logged. You see that I'm logged, but I don't see anything about link. And this is because I have to specify what link I would like to manage. I am now in TCP mode. The indication is that there is this green icon with TCP. I can go to the TCP IP utilities and specify address. My link is not on default because I am running it in my home network. Okay, I add this terminal. You can add more. Yeah, for example, if I don't. It's just a list of IP addresses. You can have all links which you are managing. And now if I need to connect to my one exact link, I have to select the right IP address. I can simply select, double click. You see here I select this one and it's connected. When I close this one, you see immediately the radio status. You see a link stat or local station, which is in my case terminal B because I specify IP address for terminal B, and you see remote station, which is local remote terminal B. Sorry, I'm connected locally to terminal B. This is this one. This is local, and remote for me it's terminal A. This is the welcome page or status page, and you see all critical parameters here. You see that there is no limit on license. This system we have, I didn't mention, but we are able to generate license for some limited time that your system will work just, I don't know, till end of July, end of September. It's useful for some trial. If you are doing some trial, you can ask us, okay, we have this link, but for some period we would like to have a time limited license, and we can simply generate license file, and you are able to limit usage of the link by this date. You see what is the system. I am using this 1.25, and I have two Ethernet ports, gigabit, it means metallic, and I have also optics port. This is the identification, what is my ODU configuration, what is the license, and what are the user port. Then in ODU section, I have information, what is my transmit frequency, receive frequency, what is my maximum power which I am allowing on this unit. In this case, it's 10 dB, and whether automatic transmission power control is on or off. And then I have receiving information. I see what is the actual transmit power, what is receiving level, and what is temperature inside of box. And I see also some error state. I think we don't have time to check everything, but you see all key statistics. You see the radio link, you see whether there is some error rates, and you see also, you can also see, if you click on the opposite side, whether signal is coming to your user port. You see line 2, line 3, line 4. This is the statistic page. For statistic, if you go to the supervisor, select service utilities, there is option graphs, and this is very useful if you are doing some troubleshooting or checking that everything is okay. These graphs, you can see, you can read local station, it's local terminal or remote terminal, and you can select more parameters. You can select receiving level, signal to noise ratio, transmit power, rate, what is temperature box and whether there are some error seconds or not. And you can select different interval. You can look 1 hour back, 6 hour back, 12 hours back, 1 day, and 1 week back. For example, I can select 6 hour receiving level, and if I press load, you see system is providing me what was the receiving level. I started like 5 hours ago this link. Then there was some changes that the receive level was gone, and after it's stable. It's logical because I'm using attenuators. I'm not running live link. I have 2 boxes behind my desk and using fixed attenuator. If you look for temperature, it will be different. You see it was startup. It was around 20 degrees and then going slowly up, and now it's on 40 degrees, which is still normal operation temperature. If you need to check the remote, you can simply check from local to remote, and again load it again, and you see similar graph. Transmit power, same value. You see how system is changing transmit power. If I select local station, there will be different because I have different setting. You see one side it's limiting to 8 dB, and second it's to 10 dB, and this is why this one is on 6 dB maximum, but this one will go up. It's going up to 8 dB. This is for some management or some troubleshooting that you can easily identify what was receiving level, transmit level, if there was some issue with error at seconds, and so on. If you need to make configuration, you have this set windows, and first one it's tune station. And now I would like just present what is a real big advantage of this tool. You see here there is parameter which is called tune link. If I click this tune link, and now what I'm now trying to do, changing the channel. Now I am running on channel 7181, and now I would like to change to different one. If I don't use tune link, I have to be careful. I have to first go to the remote side and then change the local side. If I select tune link and select new channel, remember now we are 8171. I will select this one. You see I change it. I have some loss of the communication, but very shortly link is up again, because the SES takes care about what end is to be first one for change and what is the second one. And now you see also how ATPC is working. Yeah? I have level minus 50 dB, and system is slowly changing output power to achieve right value of TX. You see now minus 50 it's my threshold, and second, and now everything is finished. Terminal B, it's shooting just 4 dB and receiving is minus 50. Terminal A, it's using 6 dB and receiving it's minus 50. Now I have still some space. You see in this case I'm using 4 dB, but maximum it's set to 10 dB. I have additional 6 dB, and here it's not so good because it's 8 dB and 6 dB it's used. I have just 2 dB. This is because I set it on this way, but to have full functionality, or how to say, the maximum power, I have to do in the way that I am just now setting to 10 dB, then I am setting 20 dB as power level, and then return back to ATPC. And now you see what was changed. Set power TX, it's set to maximum 20 dB. In this case 20 dB it's maximum, and it's technical limit of the device. And ATPC, it's automatically controlling what will be level of the signal. On the opposite side, I am for some reason on 8 dB, but I can do it same. I can go to the power TX, set manual. Oh, sorry. I have to first switch to this one. Set manual, set 20, and activate ATPC. And now system is configured for full, how to say, maximum availability, because ATPC is set to 20 dB and system is increasing, decreasing power based on these requirements. Next one, it's important, it's management properties. You can here, you see now we have threshold on minus 50. You can change it if I specify minus 45. You see system is immediately changing. This side is slowly changing to achieve -45. Then I have IP stack management. This is what you expect. It's setting of IP address and setting for SNMP and some access list. And the next one is Ethernet properties. And this is the most important. Remember what I mentioned before, that you can configure a system as 2 independent pipes or 1 pipe. You can specify different frame size, and this is exactly what you see here. Traffic mode, remember 1 channel or cross connect. Jumbo mode, you can select whether you will support VLAN frames with 1 tag, with multiple tag, or even you can go to the jumbo frames. You have specification what port, physical port will be used for management, and you can also activate VLAN. If you are running some VLANs, you can specify, okay, VLANs are active, and VLAN for management it's 650. And the good is that from this tool you see that this Ethernet properties I can change for the local and also for remote. It's logical that you have set it on the same way on both sides, but if for some reason you need to do it asymmetric, you can do it here as well. Another command is about QoS, and we are for some reason QoS it's not allowed because it's doing separate window, and it's okay. Now you see QoS, and you have configuration. You can use for QoS. You have possibility to use VLAN tag. It means priority bit in VLAN tags. You can use type of service or diff service. It's indicator on layer 3, and you can mix it. You can use, okay, now VLAN has higher priority than DSCP, and or you can use DSCP has higher priority than VLAN if you have mishmash on priority bits on VLAN or the and DSCP. You have the specification for line 2, line 3, line 4. Each port can have different setting. In modem port, remember, if you have 2 channel, this cross connect, you have 2 channel, channel 1, channel 2. You are saying how you will serve the queues. And in global setting, you have mapping if you need to change. We have 4 priority queues, and you have mapping between priority bits. It's on this way, and you have also mapping between DSCP and priority queues. Regarding the alarms, it's just mapping how alarms are mapped. But for some troubleshooting, it's useful this historical alarms or history of alarms, and you see system is now reading from the device up to 600 events, and it's working that on the first one, starting from 1, it's real first events, then around 256 we have here, or 300. It's alarms which are like first 300 alarms, and from 303 till end of the file, system is putting last 300 events which are happening with the system, which is useful if you have for long time link running, that you are not losing first data and last data, and anytime if you are doing some troubleshooting and you need fresh data, you can simply make clear, and you are clearing this history, and it's now starting from the startup. In options, some settings, just very quickly. Channel table, it's important because we have channel table. This is how channels are configured. And remember, if I did before this tune station, there was this 3 channels in the table, but we can also use another table, and this is what we can really do very flexible. I can go, okay, I will not use the table which is named John, but short table. And now you see this yellow indication that something wrong with channels. It's not affecting the user traffic. The link is still going on a channel which you program. which is not a program, but now you have to go to the tune station. Again, use the tune link, and if you go to the set channel, you see these two channels which are recommended by Etsy. It's 7282 and 84574. I will select, for example, this one. Now again you see system change it, and now it's slowly changing the receiving level of the signal to achieve this 50 dB and 45 dB. I think it's all from my side. We can now look for questions and check if there are some additional questions. Okay, I see from Eddie. It's in our documentation. What is the question is, what is the maximum RX level before saturation? The critical level is minus 30 dB. If you are receiving stronger signal than minus 30 dB, you can destroy something on the receiver side. And for alignment optimum, it's around minus 40. It means if you have signal between minus 30 to minus 50, it's perfect. Signal stronger than minus 30 can destroy receiver, and definitely if you are receiving signal stronger than minus 20, you will damage permanently something on the receiver. The answer is minus 30. It's the strongest signal allowed on the receiver side. Okay. I think there was some discussion about cables. I will not comment. Okay, you can use cable which is okay for you. Just be careful. You have to make good water protection when cable is going to the units. And also, if you are installing a unit in some noise environment, just be sure that there are no interferences inducted on the cable. And I think it's all from the question. Oh, there is, okay, there is another question. When installing using optical connectivity for the link, do we need copper connection to the configure settings? You need copper connection, at least one, to have power on the unit. But when you have, and you have two options, you can use STP cable going to using the line 3, or on user port, if you go back to the presentation and there is this user section on ODU, there is connector for direct 40 volt ADC connection. If you connect this 40 volt ADC directly to the ODU, just keep in mind that there is no surge protection on this port. Surge protection is just on STP cable, but you can use it. You can just put power, and then you can access the management over optic, because it's line 4. You have to configure that your management will go to line 2 plus line 4 port, and then you will have management over optics. If you go to the documentation, there is a lot of scenarios, and one of these scenarios is direct power to ODU and optical fiber to the data network. And I think it's all from the questions. Am I right, John, or do you see some more? We discussed the cables, RX level, and these optical fibers. Okay. In this case, if there is no more question, thanks for your time. Later on, you will receive the presentation which I use during this webinar. And if you need anything from documentation, utilities, just go to our www.sub10system.com web server. There is also another server which is support.sub10system.com, which is like not fully official, but it's server which is used by us. Maybe I can, before we finish, we can. You can use this web page. There are some additional information available. And definitely, if you will cooperate with us on a regular basis, there will be, how to say, secure section that we will provide you login name and password, and you will be able to access some additional information. Okay, I don't see additional question in this case. Thank you again for your time. I hope that weather it's excellent, because in my country it's just 6 p.m. and it's sunshine, which is unbelievable because forecast was rain. And in this case, I wish you good evening, and I hope you will be in touch soon during our additional training.